The third equation, we solve for A. This is the third equation, we solve for A. Now, so we need the other two equations. I wrote them down here. Plus 3C equals negative 59. Okay. And what we have to do is wherever we see A in both of these equations, we have to substitute in B plus C minus 12. Okay. So B plus C minus 12 plus B plus C equals 6. And then 2 times, I'm going to draw a line right here, B plus C minus 12 minus B plus 3C equals negative 59. Okay, so now we need to combine like terms and get this down to where we have BC equals whatever. Okay, so we've got, nothing's going to change our signs in here. So we've got 1B, we've got 2B. We've got 1C and 1C, so that's 2C. C minus 12 equals 6. All right, so 2B plus 2C, we add 12 to both sides, equals 18. Is everybody good there?
What do you use this for?
It's a process of thinking as much as anything. I can't give you a specific one unless I said Isaac bought 5 tacos, 3 sodas, and 2 bags of chips for $15. Then Hayden bought 2 sodas, 9 tacos, and 3 bags of chips for $16.15. And then Alicia bought 2 tacos, 2 sodas, and 1 chip for, I don't know, $7. And then we could figure out the price of the tacos, the sodas, and the chips.
Okay.
Okay. Would you actually ever really do that? No. Okay. Well, but it wasn't available for whatever reason. Maybe the nacho cheese sauce for the tacos got spilled all over it or something. I don't know. Okay. I don't have a specific reason for using a 3x3 system right off the top of my head. I'm not going to lie to you and tell you something and it's just totally not true. Okay. Where should all our phones be? Okay. Okay. All right. So, anyway, so is everybody good with how we got to here? Okay. And this is one of the skills you're going to need in pre-cal, or if you go into even nursing, you're going to have to work with systems of equations, figuring out some medicines and how they work with each other and mix them. And so there are some other uses, but I can't give you a specific instance. Okay. All right. So now we need to do the same thing here. Okay. So we've got 2B plus 2C minus 24 minus B plus 3C equals negative 59. So 2B minus B is B. 2C plus 3C is plus 5C. Okay, I'm going to add my 24. So we equal negative 59 plus 24. So that's what, 5. And that's 3, negative 35. Is that right? Somebody check me. Okay. So we've got that. Notice we have B and C and we have B and C. Okay. So now we do what we've been doing using these. So we've created a 2x2 that we're used to now. All right. So 2B plus 2C equals 18. And B plus 5C equals negative 35. Well, we're still using substitution, so that means we need to solve for that B. That's the only one that has that coefficient of 1. Do what?
I can't combine these, so it wouldn't be like 3B.
Well, that's another way, but right now we're doing substitution. So we're going to stick with that. And then, yes, we could stop there and do the elimination. Okay?
So can you stop like the bottom and do like minus 5C?
Correct.
And take it over so that you negative 35 minus 5C?
Correct. Okay? And then we take that and we plug it into the other equation. So we've got 2 times negative 35 minus 5C plus 2C equals 18. And we start cleaning it up. So that's negative 70 minus 10C plus 2C. So negative 70 minus 8C equals 18. Thank you, Kaylee. Okay. Thank you, sir. Okay, so we've got plus 70 and plus 70. So we have negative 8C equals 88.
Jamie, it's off by negative 8. Would it be negative 11 or plus 11?
Negative. Okay, because we have a positive divided by negative gives us that negative. All right, so we've got C. All right, so we take this and we run back over here and we plug it in and we figure out what B is. So B plus 5 times negative 11 equals negative 35. So B, that's negative 55, so we have to add 55 equals 0, 20. Is that right? Okay, so we've got B and C. All right, well, we're done with our 2x2 system. So we run back up to the top and we grab that equation that we started with, which was this last one. And we plug in everything but A and figure out A. So A minus 20 minus a negative 11 equals a negative 12. All right, well, that goes plus. So 20, negative 20 plus 11 is going to be 9. Is that right? A minus 9 equals negative 12. And then we add 9. So we get A equals negative 3. Is that right?
Yeah.
Okay. So there's, oh good, those are the same answers. Okay. So you write it as an ordered pair. Okay, so down here, you put it in alphabetical order, A, B, C. So negative 3, 20, and negative 11 is your solution. So it just kind of stretched it a little bit further. Didn't change anything really. Okay, but we added a few more steps. Okay, so flip over. And what we're looking at here, they're going to talk about some special cases here. Okay, so a 3x3 system can have solutions at exactly 1 point. Such as x, y, z. Okay, that's when all the planes that are represented by the 3 equations intersect at one location. And these pictures are really kind of hard to, let's see, we've got one here. We've got one here.
I only see one.
Yeah, it's hard to pick up on them all. Okay, I think
I only see 2.
I only see one white one.
you have the white one, you have the gray one, and you have
Clear.
the dark one.
I see the gray one, the black one, I did not see the white one.
Okay, the white one's really hard. It's like I said, it's really hard to pick up on. Okay, I can better show you, rather than these, let me show you with pencils. I can find them in. There's one. Okay, I got 3 different ones. Okay, so see if you can wrap your head around this. Okay, so we've got 3 lines that are represented by 3 different pencils. Okay, so if they all work together to have a solution, that would be like them all coming together at one point, right there. Okay, does that make sense? All right, so that's normal. That's being able to find the answer. But sometimes you might have one line here, one line here, and maybe one line here. So these 2 have a solution, and these 2 have a solution, but they don't all work together for one solution. Does that make sense? Okay? All right, and then the other case would be the other special case. This is one special case. The other special case would be if they all are essentially the same line, but they're written differently, so you don't notice that they're the same line at first. So then you have infinite solutions. Does that kind of sort of seem like what we did before?
Mhm.
Okay, those pictures are really, I can't reproduce those pictures. It's just not working in my head right now. Okay, but this was trying to show you that you had one solution. This was trying to show you, I think the other one was like off to the side here. So it looks kind of like an H. Okay, and you have 2 solutions, but they don't all 3 work together. And this one's showing you that they all cross in the middle and they become the same line. Okay, so your regular answer, no solution, or infinite solutions. And you could also have a no solution like this too for the system of 3. Because these 2 work, these 2 work, and these 2 work, but they don't all 3 work together. Does that make sense?
Mhm.
Okay, all right, so now, so let's fill in a few little blanks here. If the system has no solution, one of the variables will eliminate, resulting in a false statement, such as 0 equals 1 or -3 equals 10 or whatever. Okay? All right. It occurs where there's no location where all 3 planes intersect or all 3 lines. Okay, if the system has infinite solutions, one of the variables will eliminate, resulting in a true statement, such as 0 equals 0 or 10 equals 10 or -5 equals -5. Okay, and that means that they're all in a line, they're all in the same line. So all the planes are exactly on top of each other. All right, so we're going to get some examples of these. So which one of these variables do you want to solve for in which equation?
Shortest one.
Okay, so solve for y. All right. So if we take that, we have y equals 6 minus 3z, right? Okay, then we have to plug 6.
Caution was minus the.
Yeah, minus 3z, minus 3z.
Oh, okay.
Okay. So then wherever we see y in the other 2 equations, we have to plug in 6 minus 3z. So we've got x minus 2 times 6 minus 3z minus z equals 3. And then we're going to have 2x minus 3 times 6 minus 3z plus z equals 9. Okay, so we need to clean those up. All right, so we've got x minus 12 plus 6z minus z equals 3. So we've got x plus 5z minus 12. Add 12.
Is that 52 or 53?
This is a z.
Oh, that's a Z?
Yeah, my z's have a bar through them because otherwise you wouldn't
No,
know the
it's so
difference.
small.
Two.
It looks like a 3.
Sorry. All right. So x plus 5z equals 15. All right, so there's one of our system of two. And then we've got 2x minus 18 plus 9z plus z equals 9. 2x plus 10z minus 18 equals 9. Add the 18. And it equals 27. Okay, so here's our system. All right, so I'll solve for x in this one and then plug it into that one, right? So this is going to be x equals 15 minus 5z. And then we plug in here. So I've got 2 times 15 minus 5z plus 10z equals 27. So that's 30 minus 10z plus 10z equals 27. Okay, so the 10z's go away, and we're left with 30 equals 27. It's a false statement, so there's no solution.
Oh, matchup.
Okay? And you like that because then you get to just drop all that mess and go on. Okay, so what do you want to solve for in this next one? The last one, okay, for A or B? A, okay. So we've got A equals 15 minus B minus 3C.
Wait a minute, where'd you get the 15? Oh, at the end. You just
Yeah, because the 15 was already there. Okay. Now, all right, so we're going to take that A and we're going to plug it into both of these equations. So we've got 2 times 15 minus B minus 3C plus B minus C equals 5. Okay, then we plug it into the other one. Whoops. And we've got 4 times 15 minus B minus 3C plus 2B minus 2C equals 10. Okay, so we need to clean them up. So we've got 30 minus 2B minus 6C plus B minus C. So 30, negative 2 and a positive B is a negative B, minus 7C equals 5. And then we move our 30 over, so negative B minus 7C equals minus 30, negative 25. So there's one of our 2 by 2. Okay, so here, 15 times 4, that's 60, minus 4b, minus 12c, plus 2b, minus 2c, is 10. So 60, negative 4b, and a positive 2b, is a negative 2b, negative 12c, and a negative, so that's a negative 14c, equals 10. Okay, so minus 60, negative 2b minus 14c equals negative 50. Okay, so okay, so these are our 2 for our 2 by 2. So we have to solve this one for b and then plug it in, right? Okay, so negative b equals negative 25 plus 7c. Divide by negative 1, so that's positive 25 minus 7c. Okay, so we take that and we plug it in here. Negative 2 times 25 minus 7c minus 14c equals negative 50. Okay, so negative 50 plus 14c minus 14c equals negative 50. Well, our 14c's go away, and lo and behold, we ended up with a true statement. Okay, so since it's a true statement, that means we have infinite solutions. Okay, any questions on that? I know that's kind of tedious. It's got a lot of itty bitty steps. Okay, when I did this with 3rd and 6th period, third, we chose to solve the first one for B.
Is that a bad idea?
No, that's kind of the beauty of these things. And maybe it's just because I guess I'm a math geek at heart, even though I'm not a purist by any means. We did all that, and before we even got to this one, when we plugged in for the second equation, when we plugged in, we got a true statement. Okay, well, just for grins, we went on and started working over here, but you don't have to even finish it because it's going to go away. So, because once you have this, and this right here stops the whole process. And once you get a true statement like that, it just means you're going to have infinite solutions. So no matter which one you chose to work with, we still got the same answer. Okay, that's what I think is so cool about it. But like I said, I'm a geek. Okay, so these last two. Will that work? I'll put it back up for you. These last two are actually easier, or I think they are, because what they give you right off the bat on the last two problems?
I already give you the numbers.
They gave you the solution numbers, yes. Okay, so what do you have to do? They're asking you, is this really a solution? All you have to do is plug it in. Do you plug it into one equation, two equations, or all three?
Oh,
You have to plug it into all three. That's the only bad part about it. Okay, but they gave you the answers, and if it doesn't work in one,
And the numbers go in alphabetical order. So,
right,
however,
right,
that's really easy.
right. Okay, so for instance, Hayden, I'll clear this up for you in just a second. -7 would be my H, 3 would be my J, and 1 is my K. Okay, so all you have to do is plug it in. For the first one, -7 plus 2 times 3 plus 1. Does that equal 0? -7 plus 6, so that's -1 and +1. 0 equals 0. We're good. Okay, then 2 times -7. What happens if it doesn't work in one of them, but it worked in two of them?
that's not okay.
It's still not okay. It has to work in every single one. -3 plus 10 times 1. And that should equal -7. So -14 minus 3 plus 10. So -17 plus 10 is -7. So that one's a yes. Okay, so do the second one.
Don't we do the third one, right?
Hmm,
So then we need to do the third one from A.
we do. Oh, duh, you're right. I'm sorry. I guess I'm just ready to be done today. Plus 4 times 3. Third one, minus 2
Oh, I
times
thought
1
that's the one that we was doing by ourselves.
equals 3. So -7 plus 12 minus 2 equals 3. It's 5 minus 2 is 3 equals 3.
So yes.
So 1 is definitely a yes.
Wait, so
Mm-hmm.
so A would be 5 and then B is 6 and then C-
Correct.
okay.
Yes. And if it helps, label them.
So you can put 5A plus 6B, or you don't do that?
Mm.
Or are you just talking about putting them overhead?
Yeah, just put it
Oh, okay,
overhead
okay,
so you
okay.
see that A is 5 and B is 6 and C is -1. Mhm.
I got the next one, so.
That's fine.
On number 2, would it just be 0 equals 2?
Here, yes. 0 equals,
This is starting off with a-
Yeah.
so much.
yeah, 0 equals
Because I
negative 2.
looked at those notes recently, but I was like, I'm thinking 0. 0 is just 0.
I just didn't finish it. I'm sorry. Okay, so is everybody good on that process? Okay. I'm being lazy today. I'm not going to make you start on anything right now. Okay. 14, we got what, 10 minutes roughly? 11 minutes?
Mhm.
So just leave your papers out and look busy for me in case Mr. East or some other higher power wanders through, please. And, well, Ms. Berry won't be back for 14 days now, so,
No dress code.
I won't say there's not gonna be no dress code, but mind your manners, okay? And then they won't fuss too much. All right, so, tomorrow, we will be practicing this, on a worksheet, but I just don't see any need to push today. I'm tired. Y'all look like you're as tired as I feel, so we'll just call it a day.
Still got a paper day.
So if somebody, Hayden, did you get what you needed here?
Yeah, I'm good.
Okay. So Michaela, what you might want to do is, if you want to go to the library and print out the test and work on that, and then let me have that. I'll take your review after the fact. Okay? So,
Do it on my phone.
sure, if you want to do that. Or actually, you know what? I might have, which I think I do have, copies of the test and the review here. Here's the review. Let me find the test for you. And then you can just write it all on there.
Can I finish it today, just bring it to them?
Yeah. Let's see. Oh my God, I better get right here. Let's see. Of course not. Let me go print them. These are all, yes. Okay, Michaela, here you go.